right, so with an SAT right around the corner, let's run through 10 of the hardest questions the SAT has put on the test in the last handful of years here. So I strongly encourage you to pause the video and take a shot at these questions on your own, and then work through and watch how I kind of work through them here. So this first one here, we're told a circle in the xy plane has a diameter with endpoints -1, -3, and 7, 3. If the point 0, b lies on the circle and b is greater than 0, what is the value of b? Well, if I ever am given a question and I don't have a figure, I pretty much always want to draw one because it's going to let me start to see what's happening with the question a lot easier. Doesn't have to be perfectly scaled or anything, it's just there to serve as a helpful visual cue. So we could have the point 7, 3 and -1, -3. And now what this starts to let us see is one of the two important principles we always want to think about for difficult circle questions on the SAT. And this is that we can find the center of a circle given any two endpoints of a diameter. The reason this is important is because since we're looking for the point 0, b, we have to plug 0 in for x into our circle equation. And our circle equation is x minus h squared plus y minus k squared equals r squared. This is really important to have memorized. It shows up all the time on the SAT. H, k give us the center coordinates of the circle, and r squared gives us the radius squared. So what we can now do here, though, is given these two endpoints of the diameter, we can use the midpoint formula to solve for the center of the circle. So we can simply do -1 plus 7 over 2, comma, -3 plus 3 over 2. That's going to give us the coordinates of the center of the circle of 3, 0. So now we've solved for a significant part of our equation here. We're going to have x minus 3 squared simply plus y squared because the y coordinate of the center of the circle is going to be 0. And now we need to figure out our r squared. Well, since we figured out that the center of the circle is 3, 0, this brings us to our second important principle to solve all these difficult questions on the SAT, and it's kind of just the definition of a circle. If we know the center and we know any point on the circle, the straight line distance between the two gives us the radius. So you could use the distance formula, but what I always prefer to do is simply to make a right triangle to solve for the straight line distance. So what I can see is from 3 to 7, I move over 4 coordinate units. From 0 to 3, I move up 3 coordinate units. And now I very simply can just do a squared plus b squared equals c squared. And that's going to let me know that this is 5. This is also a 3, 4, 5 triangle, which is a common Pythagorean triple that shows up on the SAT. So it's a great thing to watch out for. So now I know that my r squared is going to equal 5 squared, or 25. Well, now I'm basically home free. I can solve for b by plugging 0 in for x. So when I plug 0 in for x here, I'm just going to get -3 squared plus y squared equals 25. And this will then become 9 plus, and I'll plug b in here actually, so I'll plug b in, b squared, but that's our same y value, plus b squared equals 25. And then we will simply get that b squared equals 16. And then we will get that b equals 4. And that gives us our correct answer here. The most important part with these circle questions is really remembering those two principles, and the rest of the problem isn't super difficult. Now the next one we're going to take a look at is a very tricky exponent question here. It's a little bit of a strange looking one when you first see it. We're told if 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? Well, one thing that I always want to keep in mind, this answer is pretty much never correct to start with though, but for exponents in particular, is if I want to apply my exponent rules, I need to make my bases the same. So the first thing I want to see here is, well, how can I make these bases the same? Well, I can reduce 8 down to a base of 2 because 8 is the same as 2 to the third. And so I can rewrite this as 2 to the 3x over 2 to the y. Now some students do this and they still kind of get stuck. But if I asked you what 5 to the 7th over 5 to the 4th is, as long as you're comfortable with your exponent rules, you'd probably really quickly be like, oh, that's 5 to the 3rd. I know I'm subtracting them, right? So this is no different than 5 to the 7 minus 4. Well, since we're given this value, if you're ever given a statement like this, you pretty much always are going to have to substitute it in. I can re-express this as 2 to the 3x minus y. And now because I'm told that 3x minus y equals 12, I now can see that my correct answer is going to be 2 to the 12th when I plug in 12 for 3x minus y. Now here is another killer exponent question here. So this one made pretty much everyone on the test that took it miss the question here. Which of the following expressions is equivalent to negative 4x cubed to the 2/3 power? Now, tons of people just give up on questions in the SAT way too early. So one thing you want to do is always see if there's like kind of low-hanging fruit we can solve for. So what we can think about is, well, this is going to be negative 4 to the 2/3 and x to the 3rd to the 2/3. So this is going to be applying our power rule. So we'd be multiplying it by the exponents. And well, negative 4 would just be to the 1st. So this is just going to become negative 4 to the 2/3. But x to the 3rd to the 2/3, 3 times 2/3 is going to give us x squared. So even if we just get this part of the question correct, we can eliminate a and we can eliminate b because they have x cubed values. So now we can really go through and we can solve for the rest of this question. Well, a really important thing for solving the trickiest exponent questions is how to go from our fractional exponent to root form. And so we can re-express this as the 3rd root of negative 4 squared. The denominator is your root index. The power is the power you're going to see underneath the root. Well, negative 4 squared is 16. So we're going to be taking the cube root of 16. And this is where the problem gets really fun. We're going to have to use our root tree here. Well, this could be split up into 8 times 2. 8 can be split up into 2 times 2 times 2 times 2. So since it is a cube root, we can pull our triplet out from underneath it. So here we can pull the 2 out, and what this will simplify down into is 2 cube root 2. Now we can basically just bring our pieces back together. We're not going to have the x squared underneath the root, so this now just becomes 2x squared cube root of 2, and we are able to find our correct answer. This is probably the hardest exponent question the SAT has ever put on a test because we're involving so many difficult pieces as we're going through. Now, the next one here is probably the toughest system of equations question they've ever put on a test. So I really challenge you to try this one out on your own if you can. The total distance d in meters traveled by an object moving in a straight line can be modeled by a quadratic function. And so I always want to watch out for little details like this that are going to help me know what I'm doing later on. If it said linear function, I'd be approaching the question very differently than quadratic function. That is defined in terms of t, where t is time in seconds. At a time of 10 seconds, the total distance traveled is 50 meters. At a time of 20 seconds, the total distance traveled is 200 meters. If the object was at a distance of 0 meters when t equals 0, then what was the total distance traveled by the object after 30 seconds? Super tricky question here. But as soon as I see quadratic function, and for pretty much anything on the SAT, what they're always doing is they're taking basics that you're familiar with and they're presenting it in a novel or unique manner. So if you're stuck, always think back to the basics. It can serve as a really good starting point for what to do. Well, I know that my quadratic function could just be expressed as the standard form would be f of x equals ax squared plus bx plus c. And now what we can kind of see is we're given 3 different points. We're given the point 10, 50, 20, 200, and 0, 0. Well, this is going to be our y-intercept. So since the object is at a distance of 0 meters when time equals 0, our c value is going to equal 0. So we can completely remove this. Our quadratic function is going to be an ax squared plus bx1. And now what we can see is that this is our input here. This is what we're plugging in for x, and this is our output. Once again, input, output in the function. So we can go ahead and write this out is 50, that's our output, equals a times 10 squared, which is going to equal 100. So we'll rewrite this as 100a because we are squaring the x value we're plugging in for, plus 10, that is a very bad 10, plus 10b. And we can do the exact same thing with the second equation of doing 200 equals a 20 squared. So this is going to be 400a plus 20b. Now what we have here is we have a system of equations. So the easiest way that I like to solve system of equations is just by stacking and eliminating. So I can take this top equation, I can multiply it by -2, and then I'm going to be able to cancel out my b values. So what I would get is -100 equals -200a minus 20b. So now when I add these two equations together, what I get is 100 equals 200a. This is going to tell me, as I divide by 200, a equals 1/2. Now I very simply can plug that 1/2 back in to either equation to be able to solve. So we'll get rid of a little bit of this work here now. So now what I would do is I would just use the top one here. And if I plug 1/2 in for a, I'm simply going to get 50 equals 50 plus 10b. That means 10b is going to equal 0. Therefore, b will equal 0 in this case. So what I actually have is my function is simply 1/2 x squared. So now if I'm looking for 30, I'm simply doing 1/2 of 30 squared. 30 squared is 900. 1/2 of 900 is going to equal 450. And that gives us our correct answer. Very, very difficult question, but this is a question type that the SAT has really loved the last few years, with both quadratic functions and linear functions being solved in very, very similar manners here with a system of equations. A handful of examples of this kind of in our book as well. Now we'll get to the next one here. The equation 9x plus 5 equals a times x plus b, where a and b are constants, has no solutions. Which of the following must be true? Now, as always, as I said, everything on the SAT is coming back to basic principles, presenting it in a little bit of a novel way. Well, no solutions can be equations like this. We can have x plus 5 equals x minus 2, or we could have 4x plus 3 equals 4x plus 4. Very simply, the x's must be the same, and the numbers, in a really simplistic way of thinking about it, must be different. So now I have the rules that I have to follow as I go through. So the first thing here I'm going to do is I'm going to distribute the a through. So I will get 9x plus 5 equals ax plus ab. And so now I can go ahead and I can work to meet this first constraint. My x values must be the same. Well, that tells me right away that a must equal 9. So this means number 1 must be true. So now I can kind of plug this in, right? So I can say 9x plus 5 equals 9x plus 9b. And now we want to work for our second constraint, and this is that the numbers must be different. Therefore, 5 cannot equal 9b, and that means that 5 over 9 cannot equal b. That means that 3 also must be true. Therefore, our correct answer is D. Now, the next question type that we're going to see here is what I kind of call like an interpreting exponential growth or decay question. These are very, very tricky ones, especially when we get a unit conversion like we will get in this question. A biologist grows a culture of bacteria as part of an experiment. At the start of the experiment, there are 75 bacteria in the culture. The biologist observes that the population of the bacteria doubles every 18 minutes. Which of the following equations best models the number n of bacteria t hours after the start of the experiment? Now, with this here, we do have to have the 75 at the front for each of these equations, so that doesn't help us eliminate anything, but because it's doubling, this part within the parentheses is going to be our rate of change. So this is going to have to bring us down to a or C right off the get-go. B and D are not written in the proper exponential growth decay formula, so we can go ahead and we can eliminate those immediately here. Now, what we have to do whenever we get to this point in the questions is we want to essentially fact check the statement here, because this is the one statement that we know is true. We know that we should be doubling every 18 minutes. So the huge mistake that most students make is they pick A, because they see the 18 in the question and they're like, oh, that looks like it's doubling if I plug 18 in for T. But because this is given in hours, we have to think about 18 minutes is what fraction of an hour? Well, 1/10 of an hour is 6 minutes. Therefore, 18 minutes can be re-expressed as 3/10 of an hour. So what I really want to think about in this equation is when I plug 3/10 in for T, which equation is doubling? Because that is going to let me fact check the statement from the question itself. If I do that, I 100% know I found the right answer. This question type is always written to make you kind of want to pick the wrong answer. So we always want to give ourselves a fact check of a statement from the question to find the right answer. And what I can see here is if I plug 3/10 in for T, 10 over 3 times 3 over 10 is going to equal 1. And that means, because it's 75 times 2 to the first, that means in those 18 minutes we will have doubled. That is how I can tell that C is my correct answer. These questions are super kind of like topsy-turvy. They spin your head around a little bit. But if you go from trying to just conceptually understand them and pick the right answer, and instead take this approach of fact-checking them and plugging a value in from the question itself, you begin to identify immediately if it's right versus wrong. If we looked at A, if we plug 3/10 in for T there, we are not going to be doubling, because 3/10 divided by 18 is not going to give us something to the first power. And that's a little bit of a secret for these questions as well. You're pretty much always looking for making it to the first power, because here in particular, we already were doing the doubling we were looking for. Now here is another very tricky exponent question on the test. So here we're told if the square root of x to the 5th over the cube root of x to the 4th equals x to the a over b for all positive values of x, what is the value of a over b? Now, as you can see, we may get a little bit of a trend here for very difficult questions. They love making us go from root form to fractional form or fractional form to root form. So what we need to know here is that the square root of x to the 5th is the same as x to the 5 over 2. Remember, the power here, our root index, is the denominator of our fraction. The power underneath is our numerator. So we're going to have x to the 5 over 2 over x to the 4 over 3. And this is going to equal x to the a over b. Now, with with exponents here, because we are dividing, we know we're going to have to be able to subtract them. So we can think about this very similar to our last question. Well, this is going to be x to the 5/2 minus 4/3. But if we're going to add or subtract fractions, we have to have them to a common denominator. Well, the common denominator of 2 and 3 is going to be 6. So we can rewrite this as x to the 15 over 6 minus 8 over 6, as that took me half a second there. So this is going to give us x to the 7 over 6, and that is going to tell us that x to the a over b equals x to the 7 over 6. Therefore, 7 over 6 equals a over b. Now, our next question is another one that stumps almost everyone here. So one thing you always want to keep in mind on the SAT is identifying x and y values, because these are going to let you plug in to solve for questions. So here we're told in the xy plane, the point P comma R lies on the line with the equation y equals x plus b, where b is a constant. The point with coordinates 2p comma 5r lies on the line with the equation y equals 2x plus b. If p does not equal 0, what is the value of r over p? So this makes pretty much everyone's head spin a little bit the first time they read through. But what I want to identify is, well, this is my x comma y and also my x comma y. So I can plug these into the equations here, so you can still see the equation nicely. So I can rewrite my first equation is r equals p plus b. And I can plug into my second equation by expressing this as 5r equals 2 times 2p, so it's going to be 4p plus b. Now here, the issue is, right, we're currently looking at an equation that has 3 variables, and we're trying to solve for r over p. So I want to get rid of the b variable. So the easiest way I can do so here is I can re-express this top equation is r minus p equals b. Get rid of that equal sign so I don't confuse anyone. So I just re-expressed it in terms of b. So what this now means is I can take this and I can substitute it in for b in my second equation. So I can write this out as 5r equals 4p plus r minus p. And this will become 5r equals 3p plus r. I'm going to subtract over my r. I will get 4r equals 3p. Now what I always want to keep in mind is what I am ultimately solving for. So I'm solving for r over p. So the next step I would take here is I can divide by the p, and then I can divide by the 4. Because now I've got rid of my 4 from here, and I've got rid of my p from here. So I end up finding that r over p equals 3 over 4. The most important step to take from this question, where most students get stuck, is always looking for your x and y values that you can plug in. The rest of this is a system of equations, albeit with very, very difficult step at the end that we have to kind of look for, but that's the real part you want to watch out for. Now here is another very difficult of these kind of interpretation questions. So before its launch, the first stage of the Saturn V rocket held about 540,000 gallons of fuel. The number of gallons of fuel f of t remaining t minutes after its launch can be modeled by the function f of t equals 540,000 times 19 over 21 to the 20t. Which of the following describes the meaning of the fraction 19 over 21 in the context described? This is actually a no calculator question as well. So this looks really, really tricky. So here we're thinking about this as in t minutes here. And what I first want to think about here is if I'm understanding the basics of exponential growth and decay questions, this first part is going to tell me my initial amount. So that's going to tell me how much I had at time of 0 as we're going through. So this is not going to be the fraction of the gallons it had at its launch because it's going to have 540,000 gallons at its launch. This is going to give me my rate of change, and this is going to be the time periods here. So what I kind of want to think about here, and this just helps with a little bit of SAT experience as well, for all these questions, you're pretty much raising it to the first power because what we're ultimately looking for is the time period where we're just doing 540,000 times 19 over 21. If we raise this to any power except for the first power, we are no longer going to be multiplying the 540,000 by the 19 over 21 because we're going to have to start squaring it or taking a root of it. So what I'm really looking for in this question is how I can change 20t to equal 1, essentially, because I need to make it the first power. So this is in minutes here, and now I start to see that each of my other answer choices are in seconds. So the real secret to this question is I'm looking for what is 1/20th of a minute, because that is going to raise it to the first power. In 3 seconds is 1/20th of a minute. That is how I am able to tell that that is the correct answer. Because as I do 20 times 1 over 20, that just equals 1. And then that is going to tell me how much fuel was remaining after 3 seconds because I've raised it to the first power. Super, super, super tricky question here. Now, the last one that we will go to is another question type that shows up on the test and gives quite a few students trouble, but what you'll actually see is this is by far the easiest one we've gone through, but this makes tons and tons of students miss this. So this is what we call a special quadratic question here. And definitely check out the kind of little course lecture I did on these because they're super helpful and quite easy once you start to understand how these are really done. Well, here we see if x squared plus y squared equals 15 and x squared minus y squared equals 10, what is the value of x to the fourth minus y to the fourth? Well, what all of these questions come around are your perfect squares of addition, perfect squares of subtraction, or differences of squares. And although you may not remember those terms, what you probably will remember is I'm writing this out is this difference of squares formula. Because you most likely learned it when you were going through quadratics in school. And if you look at this, you probably now are kind of recognizing, oh, well, I know that x minus y times x plus y equals x squared minus y squared. So all they have actually done here to make this feel a little bit more difficult to spot the pattern is they have stepped this all up a power. What we also then can recognize is that x squared minus y squared times x squared plus y squared would simply equal x to the fourth minus y to the fourth. It's the exact same pattern, we've just stepped it up a power. So all we have to do here is we have to plug these values in to find what x to the fourth minus y to the fourth equals. So we're simply doing 15 times 10 equals x to the fourth minus y to the fourth, and that means it is going to equal 150. So I hope this was really helpful for a lot of you guys about to take the test. Definitely recommend to check out some of the free lectures that I've posted here that I will be kind of linked below, and best of luck on your SAT.